Hello dear students, in this video we are going to solve some of the questions from the electrochemistry chapter. Students, reading the concepts and understanding it is not enough that you are perfect in the particular chapter. After reading the concepts, understanding is important. Mugging up the concepts, it won't work out. While writing the exam, we cannot able to reproduce those concepts in the exam. Better after doing the concepts, after reading the concepts, better we can do sufficient number of questions based on the concepts so that we will become very strong in those concepts. If we have few doubts in the concepts also, it will be clarified when we are doing the questions based on those concepts. So, in earlier videos I have done in the 16-17 videos electrochemistry, clearly I tried to explain. Please you can watch those videos. Students, my main aim is I want to become famous in the YouTube. Meanwhile, I should be useful for the most of the students in India, not in the south, not in the north like that. It is overall India. It is useful to all the students. So that's why even though I know Hindi, I am not doing the videos in Hindi because my videos should be useful for all over the students all over the India. So my main aim is my knowledge should be shared. It should be shared to all the students throughout the India. That is my aim. So please you should subscribe. If you like my videos, please comment and share to your friends so that it will become famous automatically. When we are getting number of views like that or likes or subscribers, definitely it will be very encouraging to me. So I will do, there is a more chance of doing number of useful videos also in the future, because anyway this work I will put forward till the end of my life. I don't leave this work because I feel this is a profession which gives lot of satisfaction. Definitely whatever the things, whatever the difficulties I am facing, so definitely I will overcome those difficulties. Even initial stage I am not getting the subscribers or not views, if I am getting less also, I will do my work completely in the English language only. So it will be useful for the most of the students in India. So I will continue this work till the end of my life. Whatever the days, if I am able to stand, I will be able to take the classes. Till that time I will definitely do this work. Let us continue our discussion. That is, some of the questions we will solve from the electrochemistry chapter. So students, I will do this electrochemistry questions in 5 videos. Now in this first video I will do some 10 questions, right? So let us continue our discussion. Question solving from electrochemistry. Students, in the earlier video I told you that electrochemistry redox reactions both are interlinked to each other. 3 questions we will get. So if you want, we can leave some of the topics, some of the chapters from the chemistry, but chapters like redox reactions, electrochemistry, equilibrium, GOC, the coordination compounds, P block plus 2, those kind of chapters we cannot leave. Definitely we must learn. If we are not getting the chapter electrochemistry, we should not leave it. One more time we have to read, 2-3 times. After reading that, we should not take much time while reading the concepts. Within less time only we should try to understand the concepts. When we are doing the questions, definitely we will get a clarity of every concepts which is present in the chapter. But we should not skip the chapters, some important chapters I told you. So this electrochemistry, one of the 15 chapters, right? So let us start with the first question. When aqueous solution of KCl is electrolyzed, resultant solution as pH greater than 7, less than 7, is equal to 7, initially less than 7, then increases. Students, in the electrolysis process, we have 2 electrodes. Charge on the anode is positive, charge on the anode is positively charged electrode. Electrode at which oxidation takes place is called as anode. Electrode at which reduction takes place, we can call it as a cathode. Charge on the cathode is negative charge, right? So anions will migrate towards the anode. Charge on the anode is positive, anions, charge on the anions are negative, right? So when we are taking aqueous KCl solution, so ionization of KCl will give K plus plus Cl minus, and ionization of water will give H plus plus OH minus. There is two cations, two anions are present in this solution, right? Anions will migrate towards the anode. Cl minus is anion, OH minus also anion, right? Cathode, it is the charge is negative, then cations will migrate towards the cathode. K plus and H plus, they are migrating towards the cathode, right? So electrode at which oxidation takes place is called as anode. Electrode at which reduction takes place is called as a cathode, right? So students, when there is a competition between the ions in the electrolyte, then the ion which requires a less discharge potential will get discharged in preference to the other ion which requires a more discharge potential. According to preferential discharge theory, when there is a competition between the ions in the electrolyte, then the ion which requires a less discharge potential will get discharged in preference to the other ion which requires a more discharge potential. So being a complex ion, OH minus requires a more discharge energy or discharge potential. So instead of OH minus, Cl minus will get discharged. Oxidation takes place, loss of electron at anode, oxidation takes place, which gives off Cl2 gas we are getting. So OH minus will remains in the solution itself, right? And cathode reaction, the metal which has more negative reduction potential, it requires more discharge potential. In the electrochemical series, K plus, potassium is at the top of the lithium, potassium, they are at the top. So this requires a more discharge potential than the H plus. So H plus will get discharged to convert into H2 gas. Students, in the solution, H plus is removed, Cl minus is removed when we are doing the electrolysis of aqueous KCl. Then the solution will becomes as the rich in OH minus ions and a K plus ion. If you precipitate, if you try to crystallize that solution, we will get a KOH crystals, right? So they are asking about what is the pH of the solution. OH minus ion is greater than the H plus ion. So pH will be greater than 7. pH is greater than 7. First option is right. Let us take the second question. Electrolysis of dilute H2SO4 liberates gases at anode and cathode respectively. This is also based on the electrolysis process, right? Charge on the anode is positive. Anion get oxidized at anode. Charge on the cathode is negative charge. Cation get reduced at a cathode, right? So dilute H2SO4. Ionization of sulfuric acid will give us H plus plus 2H plus plus SO4 2 minus. Actually this ionization will occurs in the two steps. First stage is H plus plus HSO4 minus it will give, and further ionization of HSO4 minus will give H plus plus SO4 2 minus it is giving, right? One step we are writing this. And dilute, then water also present, ionization of water will give H plus plus OH minus. Students, both the cases, that is ionization of water, ionization of H2SO4 is producing same cation, that is H plus. So cation will get reduced at a cathode, so H plus will reduce, will discharge it into the form of H2 gas. We are getting the product at a cathode. Anode, there is a competition between the OH minus and SO4 2 minus. Being a complex ion which requires a more discharge potential, then OH minus will get discharged, right? Anion get oxidized, that is 4 OH minus minus 4 electrons gives rise to 2 H2O plus O2 gas it is giving, right? 4 oxygens, 4 oxygens, 4 hydrogens, right? Loss of electrons is called as oxidation. So product at anode is O2, we are getting. Product at cathode is getting H2 gas. So option C is right. Students, let us take some more questions now. Students, next question. Question number 3. Ionic conductance of H plus and SO4 2 minus are X and Y Siemens centimeter square per mole. Hence, the equivalent conductivity of H2SO4 is. Students, we can write lambda EQ of H2SO4 is equal to lambda EQ of H plus lambda EQ of SO4 2 minus. Lambda EQ of SO4 2 minus. Ionic conductances is given. It is for lambda H plus is given as, this is nothing but molar conductivity, that is given as X Siemens centimeter square per mole. This is nothing but it is same as a molar conductivity of the ion. And lambda M of sulfate, it is given as Y Siemens centimeter square per mole, it is given, right? Students, H plus, that is charge is 1 unit, then its equivalent conductance and molar conductance will be same. Lambda EQ is the same as a lambda M. But for this sulfate ion, the relation between molar conductivity lambda M is equal to n factor multiplied by lambda EQ, we can write lambda EQ. So students, then from this lambda EQ value of a sulfate ion is, so n factor is the charge on the ion, that is 2. So lambda M, that is Y, it is already given, Y by 2 we can write. Students, earlier class I have given in the relation between, in one of my video I have given that what is the relation between molar conductivity and the equivalence conductivity, that is molar conductivity is equal to n factor multiplied by molar conductivity. So by using this formula, lambda EQ for the sulfate ion we are getting Y by 2. Let us substitute the values, that is lambda EQ of H plus is X, directly it is, plus lambda EQ of sulfate ion is Y by 2. So X plus Y by 2 is answer, that is B. So students, if it is a molar conductivity, we have to take it as 2 into molar conductivity of H plus molar conductivity of SO4 2 minus we have to take. But when we are using equivalent concept, directly we can take like this. The molar conductivity of sulfuric acid is the molar conductivity of H plus, equivalent conductivity of H2SO4 is equivalent conductivity of H plus and equivalent conductivity of sulfate. So by substituting these values, we are getting option B as a right, X plus Y by 2. Next question, which of the following graph is correct? Students, in the Debye-Hakel-Ansager equation, one of my video I have done that, right? So with the decrease in the concentration, increase in the dilution, if it is a strong electrolyte, the molar conductivity increases linearly. KCl, which is a salt, all salts and a strong acid, strong bases are strong electrolytes. Then the graph we will get a like this only, straight line equation. With the decrease in concentration in the reverse, the lambda M value is increasing. For the strong electrolyte it is correct, right? So then for the HCl, which is a weak acid, weak acids, weak bases are weak electrolytes. Then with the decrease in the concentration, molar conductivity increases sharply. Then we will get a graph like this, sharp rise in the molar conductivity. This is also correctly given. So students, this is based on the W and Q, it is given. Faraday's first law of electrolysis, W is equal to ZQ, right? Here Y intercept, Y coordinate is W, X coordinate is Q, right? When we are drawing a graph that is W versus Q, we will get a straight line equation which is passing through the origin. So with the slope of Z, right? This is also correctly given. All three graphs are correct. Then all of these is a right option. Let us take next question. Students, next question. Question number 5. Specific conductivity of 0.01 normal H2SO4 solution is 6 into 10 power minus 3 Siemens per centimeter. Its molar conductivity is, students, given conductivity, specific conductivity K is equal to 6 into 10 power minus 3 Siemens per centimeter. To calculate lambda m formula is K into 1000 divided by molarity. Students, here normality is given. So we know normality, relation between normality and molarity is equal to N is equal to N factor multiplied by molarity, right? So here we need molarity. Normality is given in the question. 0.01 is equal to N factor for the H2SO4 is a basicity. It is 2 into M. So from this M value we are getting 0.01 divided by 2, which is 0.005 we will get molarities. Let us substitute all the values given here. K value is 6 into 10 power minus 3 into 1000 divided by M value is this 0.005. Students, I am writing it as 5 into 10 power minus 3 I am writing. These 2 will get cancelled, right? 6 by 5, it is 0.3, right? Sorry, 6 by 5 is 1.5 5, 1.2 we are getting 1.2 into 1000, which is equal to 1200 Siemens centimeter square per mole we are getting. So which is given in the option A, right? 6 by 5 is 1.2, 1.2 into 1000 is 1200 Siemens centimeter square per mole. So option A is right. Next question, sixth question. How many coulombs are provided by a current of 0.010 milliamperes in the calculator battery that can operate for 1000 hours, right? Students, they are asking how many coulombs are provided. Charge they are asking. Charge Q is equal to current multiplied by time. Current multiplied by time. This time we need to substitute in the seconds, right? So Q, how many coulombs Q we need to calculate. Q is equal to I is given in milliamperes. Then to convert into the amperes, that is 0.01 into 1 milliampere is equal to 10 power minus 3 amperes multiplied by time we need to substitute in the seconds. 1000 into 1 hour is equal to 3600 seconds. Simplify it. This one we can write it as 10 power minus 5 into, this is 10 power 5 into 36. 10 power minus 5 into 10 power 5 is 1. 1 into 36 is equal to 36 coulombs we are getting. 36 coulombs. So option D is correct. Friends, let us take some more questions now. Question number 7. Which one of the following metals cannot be obtained on electrolysis of aqueous solution of its salts? Options are given as Mg, Ag, Cu, Au. Students, according to preferential discharge theory, which says that when there is a competition between the ions in an electrolyte, the ion which requires a less discharge potential will get discharged in preference to the other ion which requires a more discharge potential or discharge energy. So students, we know for these metals like silver, copper, Au, these have positive reduction potential values. Positive standard reduction potential values. But being more reactive, magnesium has negative reduction potential value. It has low tendency of undergoing reduction. So if for example in its solution it is present in the form of Mg2 plus. Generally Mg will exist in the solution, salt solution in the form of Mg2 plus. Then when we are taking aqueous solution, then there is a competition between the Mg2 plus and H plus. This is at cathode. Then according to the preferential discharge theory, the ion which requires a less discharge potential will get discharged in preference to the other ion which requires a more discharge potential. So negative value of reduction potential it is having, it requires a more discharge energy than the H plus. So H plus will get discharged in preference to the Mg2 plus. So we won't get Mg by doing the electrolysis of its aqueous solution of its salt. So we, instead of getting Mg, we will get a H2 only. So option A is right. Which one of the following metals cannot be obtained? Mg cannot be obtained. Next question, question number 8. Electrolysis can be used to determine atomic masses. A current of 0.550 amperes deposits 0.55 gram of a certain metal in 100 minutes. Calculate the atomic mass of the metal if equivalent mass is equal to molecular mass divided by 3. Students, we will use Faraday's first law, that is Q is equal to Z by 96,500 into, sorry, not Q, W, weight of the amount of the substance deposited is equal to electrochemical equivalence. Z is equivalent mass divided by 96,500 into Q. So Q we can write it as I into current multiplied by time. Time should be, we need to substitute in the seconds, right? W, weight of the substance they have given, students, that is 0.55 grams is equal to equivalent mass, let us assume it as E, divided by 96,500 into I is given as 0.55 into time is given as, what is the time? 100 minutes. So 100 minutes in the seconds we need to substitute, that is 100 into 60 seconds, right? Then from this E is equal to, we will get 0.55 gets cancelled, 96,500 divided by 6,000 will get, 6,000 will get, right? By transferring this 100 into 60,000, transferring to the other side of the equation, we will get 96,500 by 6,000. 2 zeros will get cancelled. Students, here it is given relation between molar mass and equivalent mass is equal to molar mass by 3. Then molar mass we can write it as molar mass is equal to equivalent mass into 3. So that is equivalent mass is 965 divided by 60 into 3, which is, on simplifying we will get it as a 48.25, which is given in the option C. Let us take 2 more questions now. Students, next question, question number 9. How many minutes are required to deliver 3.21 into 10 power 6 coulombs using a current 500 amperes used in the commercial production of chlorine? That is, options are given as 8.3, 5.3 into 10 power 4, 6420, 107. How many minutes? Time they are asking, students. Q is equal to, we know charge is equal to current multiplied by time. Time in the seconds we can substitute here. That Q is given as Q. Students, next question, question number 9. How many minutes are required to deliver 3.21 into 10 power 6 coulombs using a current 500 amperes used in the commercial production of chlorine? Options are given as 8.3, 5.3 into 10 power 4, 6420, 107. So students, charge Q is equal to current multiplied by time. Time in the seconds we need to substitute here, right? So they are asking time only, but time in the minutes. From this formula we can calculate time in seconds first, right? So T into I value is given as 500 amperes is equal to Q is 3.21, charge is 3.21 into 10 power 6 coulombs. So students, from this T is equal to 3.21 into 10 power 6 by 500. Transferring 500 to the other side of the equation, it will comes in the denominator. Then time in the minutes they are asking. Time in minutes. But here this we will get in the seconds. So 3.21 into 10 power 6 divided by 500 multiplied by 60. Then on simplifying this, students will get it as a 107 minutes. 107 minutes. So which is given in the option D is right. Next question. Question number 10, last question for in this video, that is passage of a current for 548 seconds through a silver coulometer results in the deposition of 0.746 grams of silver. What is a current in amperes, they are asking, right? Using Faraday's first law, W, weight of the substance deposited or liberated, is directly proportional to the charge that has been passed. So we can write it as ZIT. So hence W, weight of the silver, it is given 0.746 grams is equal to Z is electrochemical equivalence. Equivalent weight of the silver is same as its atomic weight, 108 divided by 96,500. This is totally Z, electrochemical equivalence. Equivalent weight of the substance divided by 96,500. This is Z into I, that is they are asking to calculate the current only. So I, it is as it is, T in the seconds we need to substitute 548 seconds. So simplify it, that is I is equal to 0.746 multiplied by 96,500. Transfer the remaining terms to the opposite side of the equation. 108 divided by multiplied by 548. Simplify it, you will get it as a 1.22 amperes. That is given in the first option. Option A is right. Students, some more questions we will do in the next video. Thank you for watching.